Thank God for climate-motivated countries. Even though a majority of the global population are calling for climate action, their desire to see the fulfillment of this ambition is seriously limited by the political and financial power of corporations that are often climate wolves in sheep's clothing. And then there are countries like Canada, New Zealand, Iceland, the United Kingdom, Australia, and Ireland who would benefit from a warmer climate. But in the main, the vast majority of the global populace are increasingly being discomforted by higher surface temperatures, and no less so by escalating energy costs. The biggest climate losers, however, will be the small island developing states or SIDS, some of which, like the Solomon Islands, Maldives, Palau, Micronesia, Fiji, Tuvalu, Seychelles, Kiribati, Cook Islands, French Polynesia, and the Marshall Islands, which as a whole or in part will be underwater in 50 years. Which will also be the fate of Tangier Island, Virginia, and Shishmaref, Alaska in the United States. The small island developing states or SIDS rebranded themselves a few years ago as the large ocean developing states on the basis of the 30% of the global economic exclusion zones or EEZs they control. This is an enormous resource. For example, the OPEC nations control about the same percentage of global crude oil production. In a paper Update 2022, a fundamental look at supply-side energy reserves for the planet, Mark and Richard Perez visualized the size and capacity of the renewable and finite resources. The finite resources like natural gas, petroleum, uranium, and coal are largely unavailable to the SIDS, which in the main have to import energy, which is a tremendous drain on their economies. It should be noted, this is a problem endemic to most of the Asian-Pacific region as well. Solar and wind, by far have the highest capacities of the renewable energy resources, but do island nations, who are largely dependent on tourism dollars to sustain their economies, want oceanfront vistas blighted with acres of solar panels and windmills? And even if they want to rely on these sources of energy, they typically can't produce them in exportable quantities, and don't have the means to deliver power to remote industrialized nations and thus derive export dollars. Some of the SIDS have geothermal potential. Much of it the result of subduction activity along the tectonic plate margins, but this energy too is only available in domestic quantities, as is their marginal tidal and wave resources. But the tiny nation Tuvalu, with a territorial land mass of 25.1 square kilometers, has an exclusive economic zone of 753,139 square kilometers. An economic multiplier of 30,000 when this surface area is utilized to produce energy with ocean thermal energy conversion. And the 39 SIDS and 18 associate members of United Nations regional commissions that face unique social, economic and environmental vulnerabilities have similar potential with the same technology. But not all ocean thermal energy conversion is created equally. Typically, with conventional OTEC, water is brought to the surface by massive pipes to condense a working fluid after it has passed through a turbine to produce power after the working fluid was first vaporized using surface heat. The thermodynamic efficiency of this process is only about 3%, and the 97% of the surface heat diluted by the cold water is dispersed outward towards the poles that in the case of the Arctic is warmed 4 degrees over the course of 1,000 years at the same time as the tropics are cooled by the same amount. Instead of using an upwelling strategy, thermodynamic geoengineering doesn't allow water to move between the thermal layers of the ocean. It instead uses the phase changes of a working fluid to move heat from the surface to a depth of 1,000 meters, which provides 226 years of global warming respite. This is accomplished with a heat pipe. It also mitigates the two greatest threat to island nations, sea level rise and storm surge. This is because the coefficient of expansion of sea water is half at 1,000 meters it is at the surface, and heat moved into deep water isn't available to melt polar and Himalayan ice caps, and surface heat moved into deep water can't power cyclones. Using phase changes of a working fluid, instead of with the sensible heat of water, heat is moved 2.5 times more efficiently with thermodynamic geoengineering than with conventional OTEC, and accordingly thermodynamic geoengineering can produce 2.5 times more energy as well. At scale, thermodynamic geoengineering can produce over twice as much energy as is currently being derived from fossil fuels. From a depth of 1,000 meters, heat diffuses back to the surface at a rate of 1 centimeter a day to the bottom of the mixed layer, and 1 meter per day through that layer. So, it is back at the surface in about 226 years, where it can be recycled to produce more work. Over the course of 13 cycles, all the heat of warming can be converted to work, and the waste heat of those conversions can be dissipated back to space, thus eliminating the problem of global warming. The two most populous countries of the world are India and China. China is the world's largest importer of crude oil, and India ranks third, importing 41% of its energy in 2022, just ahead of Japan and Korea, which import 94% and 94.8% of their primary energy respectively. Along with China, South Korea, and Japan are the preeminent shipbuilding nations, which next to renewable energy is the industry most vital to the development of a sustainable future. As are resources like the minerals and metals dissolved in the ocean that can be obtained by using ocean-derived energy. An amalgam of the SID's economic exclusion zones with the economic and technical might of the Asia-Pacific region are a recipe for a vibrant and prosperous sustainable blue economy that can thrive on the cheapest energy that can be had with thermodynamic geoengineering. Instead of vetoing policies with which they do not agree, these countries have corporations and citizens clamoring for climate action,